morning, everybody. And once again, second part of CoSSMic introduction. Though CoSSMic may be collaborating solar-powered smart microgrids. And I have to accelerate a little bit that we have enough time for the discussion afterwards. I have to push. Okay, once again, the idea of smart grid and smart grid control, very easy. We have more or less a fourfold. We have energy consumption, which is mainly a consumer, as an example. Then we have two different branches for the energy production. One is the grid, the public grid, and the other one is that what we have, for instance, on our rooftop. And then we have something in between which can do both, storing. That means it's a consumer and a producer. Depends how it works. And in the middle, you see, this is a already mentioned brain of our smart grid. This is a so-called Raspberry Pi. And this, it acts as a gateway, and this gateway, it arranges everything what's going on in the system. And already mentioned that it's an autonomous one, which is acting peer-to-peer-like. It's full of information, this transparency, but just to introduce you to the so-called smart meters situation. So in Konstanz we have here the Elster smart meters on the left side. There are two ones which are measuring the PV production, and the right side is only for the consumption. And here once again you see our Raspberry Pi. And so we developed within the project different ways for the data acquisition, transfer, and storage. And so we have, maybe for the experts, we have different interfaces, for instance, the RS485, but sometimes we have to use an analog output. It's called S0. And for the data transfer from the smart meter, which is measuring, to the Raspberry, we are using always wiring. But from the Raspberry Pi to the internet, which acts as an in-between communication system between the different households, we are using LAN or WLAN. Depends on the technical situation. Oh, sorry. And what is the system now? We have devices, they are consuming and they are producing, and you have external services. Already mentioned, we have weather report, weather data, and tariff and fees. And in between we have our system, which is more or less inside of the Raspberry Pi, the device management and the task management and the multi-agent system, which is acting as an information transfer between the different users and between the different devices. Now the next transparency is dealing with weather data. We get it from the Deutschen Wetterdienst, and we get it every 6 hours, which is pushed to our FTP, to an FTP server. And from the FTP server, the data, they are directly transferred to the single households, to the Raspberry, and okay, and the Raspberry is running a program which is using the weather data to calculate the PV yield for the next 6 hours. Or for the next 24 hours, but is refreshed every 6 hours. That was that, what I mentioned, and now let's go to the, maybe I have to go to do it. Now let's go to the tri-sites in Konstanz and Cassata. Cassata is about 50 kilometers north from Napoli. They have very, very different situations. The sunshine is quite different, and also the situation on the PV systems as already installed. But already mentioned that we have 12 user sites in Konstanz and 5. We wanted to have 12, but for some restrictions, we got only 5 up to now in Cassata, but we have a very, very large PV system included. And when we have a look on the annual share of the PV, that is what is produced over a period of a year versus the consumption of the different sites and of the different communities, then we see that in Konstanz, it's that what we selected is 1/3 is covered by PV, and in Italy, more or less 100%. And the trials are started already last year in September. So, just a look of different Konstanz industrial uses. I don't show any private uses because of privacy, but I guess these three, that's a sunny solar technique, a large PV system, that's IEC Konstanz here, with the movable battery system, and the Fruchthof Konstanz, also equipped with a PV system, and very interesting for us because there are 6 to 7 different cooling rooms, and the cooling rooms, they can be shifted by temperature a little bit. That means we have a reservoir which acts as an energy shifting or energy deposition system. Gives us freedom to decide how we will use the free energy at certain times. And now there's another example in Konstanz where we already installed, private installed, not done by CoSSMic, but from private owner, but is included in the CoSSMic trial. We have a battery system, and you see it's also possible to have a not optimized installation of the PV system, which is directly on a flat rooftop. And Italian situation, just a view. There are not so many private PV systems installed yet. And just to have to show you how it works, we have the Raspberry Pi in both trial sites, in Konstanz and Caserta, and the Raspberry is connected to the internet and the cloud server, one side, and the other side directly to the system we are measuring. And sometimes there are schools, there are large areas, so we have to introduce some repeating systems that we can get the data without disconnection. Smart grid components in Konstanz, you see we have the smart meters, so the Raspberry, when we have also smart plugs, they are a very convenient way. If it's not easy to install a smart meter directly to the consumer, then we use the smart plug, which we can use directly to the socket, and it's transmitting energy and power data to starting with a transmission rate of some seconds up to that what you need, and can also be switched. And once again, we have not only e-cars integrated, also stationary batteries as already seen. Now, that's what you have already seen in the first talk. Once again, we have here the graphical user interface, which is the link to the user itself. We developed. Here we have the weather data, for instance, and then here that's the information, how much energy comes from the grid and how much from the PV system, and how much is exchanged in energy between one user and the community. That means the neighborhood. And a scheduling system, that means, so we are still working on the scheduling system, that we can say, okay, we would like to run a dishwasher with the earliest starting time and the latest starting time, or we would like to have it ready at a certain time. And that's a community today, for instance, and let's go a little bit more in detail. And you see the graphical user interface of yesterday. These are real data I picked from yesterday, and we had very shiny. There you see that that's a consumption. And the peaks, they are more or less from 2 embedded heat pump systems. But the overall consumption is, when the sun starts, quite low compared to that what we can produce in Konstanz. Now, let's go a little bit more in detail that what we have measured and what we could learn from the measurements. There's a graph of a private user in Konstanz. You see there's a heat pump, electrical car, a dishwasher, a freezer, and a washing machine, and a refrigerator. And they are all measured. Here you see the refrigerator and the freezer. The heat pump is in black. And then you see there's a misfit in that you have the heat pump, the car loading, and the green one, the washing machine. They are all working at once. And that's what we want to get rid of. Once again, here the private Konstanz user over a year. Then you have dominating consumers like the e-car or the heat pump during the winter time, and in the summer, the overall consumption is reduced. And that's a typical trace of 1 month's generation of a 10 kilowatt power system, rooftop mounted. In July, I have to say, okay, yes, in July, because it fits quite well, because it's much more than self-sufficient. Here we have, here's a 30 kilowatt hour line, and here's also the 30 kilowatt hour line. That means we produce on the bottom, yes, maybe I have to slow down. The bottom figure shows the production, and the top figure, the consumption. And green means that's what produced, the dark greens produced and self-consumed. It's always the same value, down and up. It's the same, here and down. And the red one is that what is produced but comes out of the grid. That's the overall consumption and the overall production. And you can easily see that we cannot fulfill that we have 100% self-consumption because we have the nighttime. But if we do it on an average level, then we see only 2 days in July there's a production smaller than the household consumption. And by the way, you see that's 10, 20 kilowatt hours. That's not that's a unit which uses a lot of electrical energy. I would say the standard household with 2 people and 2 kids is, I would say, about half of that energy consumption on average. Over the year, we can trace it, and in the summertime, it's always okay with the delivery from the rooftop, but we have some problems in the winter, January, February, and still comes the problem to get enough energy from the rooftop in October. But though we, in the transition time between autumn and winter, we could also survive with a small stored battery system, which is only 3.7 kilowatt hours strong. And you see, it's breathing. It's not only charging once and then 3.7 kilowatt hours per day, but it's even more. It goes up to 6 kilowatt hours. That's the energy that is deposited into in the battery. That means it could be that the battery is charged at the morning and then it keeps calm and it's used whenever it's necessary to give additional energy to the household. And so that's one way to overcome this shortage of self-produced energy. Now, just to focus on that what I mentioned in the beginning, that stacked load peak, that means when you have at least 2 systems running at the same time, which is probably not necessary. As you can see here, charging of the car, and the yellow one is a dishwasher. That has to be avoided. And you see here the heat pump, it doesn't work in the way as it should, both together, but with a washing machine, it's quite good. That it found a way in between two peaks to get the energy, to let it run. And even when you have enough energy from the sun here, then you can overcome even a strong heat pump peak early in the morning when the water is prepared for showering, which is about 6 kilowatt. And this one here, you see the green one, that means the dark green one, it's produced, and here is self-consumed. Now, just to come to an end is when people ask, the system is collecting data, and what's going on if the system fails? So we have added a small routine which is measuring the consumption of a device, and we set an alarm threshold of 20 watt when the system is more than 1 hour, for example, below this value. Then, as you can see, that's the power consumption of a freezer. It's very continuously goes up and zero, that means 1 to 2 ratio of the power consumption. And here, that's not that the system went down, but the transmission failed for some reasons. And though the system sends out a message just to me that I have to have a look on the feed because something is going wrong, probably. Okay, now I guess I have to calm down by myself, and the last transparency is that what Svein mentioned, that we have not enough freedom to select the user systems as we want, so we started also some simulations. We developed together with our Italian and Norwegian partners, a simulator which is able that we can learn from larger and more complex systems. And what we also can do, we can use the measured data, or we can put in data or results we would like to have and find out how the situation should be realized. And so we mentioned a couple of times the freedom of the users, and the freedom of the users could be used, for instance, the washing machine, when he's able to mention at what time, earliest start time and the latest start time he wants to have the system or his device run. And it's one result. There are different washing machines and dishwashers and 2 PV systems, and they deliver a certain amount of energy, and you see all the 3 different devices, they start at different times. And so that is one way to study a system with a certain amount of freedom and some restrictions coming from the users. Okay, thank you very much. That was what I wanted to say about our experimental results we retrieved from our user sites and trial sites.